Hi guys, this is the Innovative Minds tutor. In this video we are going to work with Gauteng prelim paper 2. Yes, that was the preparatory. Yes, the preparatory of Gauteng examination 2023 paper 2 grade 12. Right. So without wasting time, let's get to today's video. And if you're new to this channel, kindly subscribe. You only click the red button and subscribe, and only subscribe once. Right. Let's get to today's video. In this video, guys, we are going to look at question 5, which was trigonometry. As time goes on, we'll look at the other questions, right? Let's put that into practice. The first one, guys, we are given that we are given a Pythagoras diagram here. This is a diagram question. First thing first, as you can see there, guys, it's in the diagram below. P is the point, 12 and 5, and we're given T with unknown variables A and B, and OT is perpendicular to OP, and PS is perpendicular to the x-axis, as we can see from this path here, right? And right, so first thing, guys, they want us to calculate the value of tan theta. We know that tan theta, guys, it's usually it's opposite. It's opposite all over adjacent. Remember, you're going to use a soccer toe. Sine is opposite all over adjacent. Tan is opposite all over sine is opposite all over hypotenuse, and tan is opposite all over adjacent. Right, then it's cos adjacent all over hypotenuse. So in this case, we are having tan. So tan, it's y all over x. Tan is y all over x. So what is interesting is that you have this as your x, your p is 12 and 5, which is a point, which is your x and y. So our x will be, in this case, 12, then our y will be 5. So the missing part here will be OP. How do we get OP? You could use Pythagoras theorem, Pythagoras diagram, Pythagoras theorem, x squared plus y squared equals to r squared. So you know that your x is 12 squared, and then your y is 5 squared, then your r squared. Then you have what is 12 squared, guys? That is 144 plus 25. That will be 169. Then what is the square root of 169? That's 13. So remember that your r can never be negative, so it will be r is equals to 13. So you're looking for tan theta, which is y all over x. So that will be 5 all over 12. That will be 5 divided by 12. Then let's go to sine. You already got 1 mark. Let's go to sine. Actually, this step we're supposed to write it here. You write it here. Then the sine, remember that it's y all over r, which is opposite all over hypotenuse. So your y is 5, then your r will be 13. So that's how you can get that 2 marks. Then let's go to 5.1.3. At 5.1.3, we're looking for the value of A if TO it's 19,5. TO is this part, which is our hypotenuse side. So it's 19,5. Let's construct this. Here it will be perpendicular to the x-axis. Because we have PST, let's name this R. Okay, let's name this R. So our y will be B here, then our x will be A, which is our adjacent side, the one that we are looking for. So in this case, because we want that, guys, we have 2 missing variables, so it will be very tedious to work with this, but there is a way. Our best way will be to find this angle. Yes, this angle. So I could say, for me to find angle O, I will say angle O plus we have 90 here. So because they are angle on a straight line, remember these are angle on a straight line, they remind you a grade 8 part. So they are angles on a straight line. So in this case, you're going to say angle O plus 90 plus theta, which is equals to 180. Then this is angle O, or you could say TOR, right? Angle O, then taking this to the other side will be 180 subtracted by 90 plus theta will be that. This will be 180. Then take out this, it will be 180 minus 90 plus theta. Then you are going to, oh, this will be negative, as well as this one will be negative. Sorry for that. So what is 180 minus 90? So we are going to have 90 minus theta. So meaning that this part will be 90 minus theta. Right. Okay. Are we on the same track? That's how it should be. So we could see from there, guys, we have angle O, 90 minus theta, and we have a hypotenuse. So remember that when you have adjacent all over hypotenuse, that's cos. So we are going to have cos 90, remember we're working at this, cos 90 minus theta, which will be adjacent. What is our adjacent, guys? Our adjacent, we were given as what? We don't know, that's A, but we know our hypotenuse, which is OT. So we are going to put 19,5. Okay, going to put 19,5. All right. This is interesting, but there's something here, guys. We can see that this is a function value because 90 minus theta, it will change. It's a co-function, so it will change to, remember this is on the first quadrant, so it will change to sine. So it will be sine theta, which will be A all over 19,5. You're right. What is interesting is that we need to find theta here. How do we get theta, guys? We already have sine theta as 5 all over 13. So you're just gonna take your calculator, second function of sine 5 all over 13. That is okay. That will be 22. Let me just punch it well. Sine sine what? Remember it's 5 out of 13. All right. That will be correct to 1 decimal place. That will be 22,6. So we are going to have sine 22. Let me just put it in 2 correct decimal place. That will be 22,62 as theta there. Then we have A as 19,5. You will then multiply everything by 19,5. Multiply everything by 19,5. This and this, they cancel. So remember, this is A we are looking for. So we are going to have 19,5 sine 22,62. So it will be corrected to 2 decimal place. That will be 0.7. Let's correct to 1 decimal place. It will be 7,5. Meaning that A in this case will be 7,5. So that's how you can get that 4 marks. Right, guys, I hope you saw that, guys. I hope you saw that. We are still winning. So you just have to remember your basics. So let's go to 5.2. Determine the value of the following without using a calculator. So right, guys, this is what you should always remember. You have at the first quadrant, you have 90 minus theta. Then you also have 360 plus theta. Then at the second quadrant, you have 90 plus theta. Then you also have 180 minus theta, as well as 180 plus theta. Right? You also have 360 minus theta, as well as a negative angle. Remember, all trigonometric ratios are positive. Sine is positive here. Then at that quadrant, it's tan. And here it's cos. So the easy way, all students take coffee. All students take coffee. So let's look at the first one. We have sine 360 minus 2x. That is on the fourth quadrant. It's only cos that is positive, meaning that sine in this case will be negative. But let's put that. Let me get a space. Let's put that into practice, guys. Right. Okay. We are at question 5. So I'll just write as it's what 5.2. Question 5.2, and we have sine 316 minus 2x. Right, so we have that sine 360 divided right, then multiply by sine negative x divided by sine 90 degrees plus x plus 2 cos squared x, cos squared 180 plus x. I mean, that's 6 marks actually. So let's start with this one. Sine at the fourth quadrant, it's negative, so we are going to have negative sine 2x. Negative sine 2x. So how is sine at the fourth quadrant? It's also negative. Okay, right. What is sine 90 plus x? Sine 90 plus x, guys, that's second quadrant, where sine is a home for sine. But since it's a co-function, it will be positive cos x, meaning that cos will take the sine of cos, right? Then let's reduce this one. How is cos at the second quadrant? Definitely we know the answers that at the second quadrant it's a home for tan. So cos will be negative. So we're going to have negative cos x. Remember that it's being squared here. So let's work it out. So negative and negative, we get positive. So all in all here we have sine 2x sine x divided by cos x. Then when you square a negative ratio there, that will be positive. So we're going to have positive 2 cos squared x. Right, so from here we could see that, guys, here we have a double angle of sine 2x. So when there's a double angle, change it. So it will be sine 2x as well as cos x multiplied by sine x, right? Check. Know your double angles well. When it's sine 2x, change it to 2 sine x cos x. So we have cos x here plus 2 cos squared x. So what is nice, is there something that we can cancel here? Yes, it's cos and cos, right? So we could cancel because of the multiplication. So 2 sine x times sine x, we are left with 2 sine squared x plus 2 cos squared x, which is this, right? So from here we can see something special here. What is that? It's a special identity, which is sine squared plus cos squared, but we have to factor out here. Let's factor out 2 in this case. So we are going to factor out sine squared x plus cos squared x. So what is sine squared x plus cos squared x? That's 2. That's 1. I mean, sorry for that. Sine squared x plus cos squared x is 1. So remember, because they said determine the value of the following, they were not looking for any variable. They were looking for a number. So our answer must be remain as a number. So 2 times 1 will be 2. The best way is that you can check. You can check, guys. You can check and substitute the integers 1, 2, blah, 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 whether it's cx, but you're still gonna get 2. So for confirmation and for checking, you can also do that, right? So let's go to 5.3. Given that cos 42 degrees is equals to root k, and that right, let's first draw our Pythagoras diagram in this case first. If this 42 degrees is at the first quadrant, so it's gonna be 42 degrees, and here it's 90 as we know. So it is opposite, which is our y, and this is root k, and we have hypotenuse is 1 because it's the same as root k all over 1, which is adjacent all over hypotenuse, right? So that's what you are going to face in this case. So you have root k x all over r. What is missing, guys? It's y. Then we can use theorem of Pythagoras. Using theorem of Pythagoras, we have x squared plus y squared, which is equals to r squared, so which is y squared. Our r squared is 1, so it's gonna be 1. Then we have our root k there squared, in which we are going to have 1 minus k. Then square root of y is going to be, so we're going to have 1 root minus k. Okay. So, but they're saying determine the value of the sine squared 69 in terms of k. Okay, how do we get that? Let's try to reduce this thing, sine squared 69. If we reduce sine squared 69, what are we going to be having, guys? We are going to have sine squared 69. Let's just say sine 90 minus sine 90 minus 21 squared there. So what are we going to have? So we know that 90 minus 21, that will be 69. So because this it's what you call a co-function, it will change to cos. So we are going to have cos squared 21. We're going to have cos squared 21. And mind you, guys, these people are too clever, no? They're too clever. So they said cos 42. We're given cos 42, no? And we have what here? We have cos squared 21. That means this thing, it might be a double angle. It means that it was a double angle. It was cos 2 times 21. Because when you say 2 times 21, guys, you have 42. So our best way, yes, this is how it should be. You're going to say 2. Remember that it was cos 2 times 21, which is equals to root k. So the best way is to change this. Remember, it's a double angle, so it will be 2 cos squared, double angle of cos. It will be 2 cos squared 21, which is minus 1, which is equals to root k. Then you could take this to the other side. So we have cos squared 21, 2 cos squared 21, which is equals to root k plus 1. Let's divide everything by 2. Divide everything by 2. So all in all, we have cos squared 21 is equals to root k plus 1 all over 2. So meaning that sine squared 69 will be equal to root k plus 1 all over 2, right? This was a little bit tedious, guys, right? This was a little bit tedious, right? So let's go to, hope you saw that without using a calculator. So let's go to 5.4. At 5.4, given the identity sine 5x minus blah 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 minus cos 5x sine 3x divided by tan x blah 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 is equals to this. So we need to prove, no? The left hand side. Let's work on the left hand side. You could see this is a compound angle of sine, no? So since a compound angle of sine cos and cos sine, let's just write this in a single trigonometric ratio. So it will be 5x minus 3x. Yeah? So divided by tan 2x in this case. So what is 5x minus 3x? Let's reduce it. It will be sine 2x divided by tan 2x. So the best way, remember that, don't forget that there is minus 1 here. Minus 1. Okay, let's try to change tan now. Remember, it's a quotient identity, so we're going to say tan divided by sine 2x all over cos 2x minus 1. So using the inverse proportion, so it's going to be sine 2x multiply by cos, and this becomes, remember, it's cos, this is 2 cos x, it's cos 2x as well as sine 2x minus 1. So from here, you could see that this and this, they will cancel. Then we are left with what? We are left with cos 2x minus 1. Cos squared, cos 2x, not cos squared, cos 2x minus 1. We could change this into a double angle of sine, because we want sine here. So we could just say 1 minus 2 sine squared x minus 1. So what is 1 minus 1 is 0. Then we're left with negative sine squared x, exactly as it is we have proven. Then we could write left hand side is equals to right hand side. Okay, we are at we're still on the right track. So let's go to 5.4.2. Determine the values for which the identity will be undefined in the interval. When something is undefined, guys, usually it's when the denominator is 0. So in this case, when we could take tan 2x and equate it to 0 at the denominator, so we are going to have 2x as well as 0 plus k. Remember the period of tan, where k is an element of integers. So if you divide everything by 2 there, we are going to be left with 0 plus k times 90. So okay, times 90, because they said 0 and 360, if you can put negative 1, 0 plus negative 1 times 90, that will be negative 90. Which is not, doesn't fall to this interval. 2, try negative 2, 3 as well, doesn't fall. Okay, let's think of another thing. Another thing, guys, is to think of, remember that where tan it's undefined, it's at 90. So this happens at 90 plus k times 180. So dividing everything will be 45 plus k times 90. So if we can put 0 here, we are going to have 0 times 90, which will be 0. 45 plus 90, which will be 45. So which falls under this part, which falls under this part. So x is equals to 45 falls under this, right? 2 marks. Another value that can fall under this, it can be 0. Yes, if you can work it out, you will get 0. So yes, we won't do a lot here. It's 2 marks. So that's how you're supposed to answer such, right? So let's go to 5.5. At 5.5, you are given that this is f of x equals to 2x minus sine squared x. So we have to write this, express this, show that this can be expressed as follows. F of x is equals to cos x plus 1 squared minus q. You could see that this is written in a form of completing the square. So the best way is to complete this. But how do we do it? We have, remember that we have, let's say, put y there. We have 2 cos x minus sine squared x. The best way, let's change sine squared x. So we are going to have 2 cos x as well as 1 minus cos squared x here. So when we change this, let's see, we have what? Right, we have 2 cos x minus 1 plus 2 plus cos squared x, right? So let's rearrange this. So it will be cos squared x plus 2 cos x minus 1. All right, by completing the square, you are going to square the coefficient and multiply it by half and square. You're going to multiply it by half and square it. So if you multiply this, if you square this, you're going to have x, cos squared x plus 2 cos x plus 1. You add and subtract. Take this negative 1 to the other side. Becomes 1, right? So then take this negative 1 to the other side. You are going to, three things that complete the square in this case. So it's this one and this. So you could just say cos x, sorry for that, cos x plus 1 squared. When you take negative 1 to the other side, it becomes 1 plus 1, which is 2. We have already proven this. So by completing the square, you can get it, right? So that's how you can work out that number, that 5.5.1. Then let's go to 5.5.2, or hence otherwise find the maximum value of this. the maximum value is to remember the mother graph here. When you remember the mother graph of this, remember we are having here cos x. So the maximum value will be 1 here. When you say 1 plus 1, it's gonna be 2, no? Then 2 squared, that will be 4. 4 minus 2, that will be 2. So the maximum value here, the max value will be equal to 2 in this case, right? So just we can do this through graphically. When you do it graphically, you could see that the mother graph of course here will give you 1 here. I mean, you'll get your max is 1, then 1 plus 1 will be 2 squared, then 2 squared will be 4. 4 minus 2,